This will be lecture 15 of our Machine Learning 101 lecture series, and today we are going to be talking about k-nearest neighbor classifier. So we'll see how k-nearest neighbor classifier works in this class, and in the previous lesson we talked about Bayes classifier, which actually derives from or works using the Bayes theorem. K-nearest neighbor classifier also uses probability, but in a slightly different way. So let's see exactly how it works by going to the screen. Now I'm not going to be reading the explanation here for you. You are going to read it by yourself and understand. We are simply going to demonstrate it using some hypothetical data set. And this formula also, I would like you to memorize it, and I'm going to explain it very clearly to you because it's really easy to understand. All right, let's see. So how k-nearest neighbor works? So let's start by, let's set up a data set. Let's say you have a data set, X and Y. Now remember in classification that the Y values has to be categorical or discrete. They are not continuous, meaning they are in classes. So you have Y1, Y2, Y1, Y2, or Y1, Y2, Y3. All of them is just 3 classes or 4 classes or 2 classes as the case may be. So let's say you have X1, X2, X3, X4, and so on all the way to Xn. Here you have Y1, you have Y2, you have Y2, you have Y1, Yn. So let's say we have 2 classes, 1 and 2. So what we can do, we can add another, let me use another color. Let's say we have another line here such that Y1 belongs to class 1, Y2 belongs to class 2, Y2 belongs to class 2 as well. Sorry, this is C2, C2, C1, Cn. So the Y values represent the classes. Here we have just 2 classes, Y1 and Y2, or C1 and C2. So what you are going to do with this data set is to plot this data set on an XY scatter plot, right? So you have to plot it in an XY scatter plot. So this is our X and this is our Y, okay? So let's just assume certain, we just plot one, we plot this, we plot this. Let's say we plot them all around, and we are plotting the other class in a different color. Let's say I'm using blue to plot the second class. So we have a pink class and we have a blue class. So now what we have is the test data set. Okay, so we've plotted the test data set, or the data set we are given. In classification, you'll be given a new data point. Let's say you are given a new data point, let's say X0, and you are told to classify it into a class. So let's say we plot this X0 and it falls somewhere here. So this is where X0 falls, and we need to classify X0 into one of these 2 classes, either Y1 or Y2. So let's represent Y1 and Y2 using color codes. So we have this, Y1 is pink, let's say pink, and Y2 is blue. Y2 is blue. Okay, so what k-nearest neighbor classifier will do, let's see the procedure. The first thing is to choose the value of k. You need to choose the initial value of k. So let's say we choose k is equal to 3. Then you need to identify 3 observations that are closest to the cross. So you have to identify 3 observations that are closest to this. So in that way, I think it should be 1, this one, this one, and this one. Okay, so now I've identified 3 observations and I'm going to enclose it. Let me enclose these 3 observations that are closest. Okay, so making not a very good circle. So The next thing is to estimate the probability for each class given the data point marked with cross. So we are trying to estimate the probability that this cross or this new value belongs to the blue class and the probability that it belongs to the pink class. So let's start with the blue class. Probability that X belongs to the blue class is simply the total number of blue classes over the total number of classes being estimated. So probability of the blue, let's say this is the blue, okay, let's just call it blue class, given the value of X of the star of the new data set, given this value, probability of the blue class given this value is simply number of blue classes over total number of items. So you have two blue classes. Let me just undo. I'll write something neat. So 2 over 3. And let's take the probability for the pink class. So probability for the pink class given X is equal to, how many pink classes are there? 1 over 3. Now remember that if we have this symbol, this horizontal vertical line symbol, it means conditional probability. So we are trying to estimate the conditional probability of this blue class X this value belonging to the blue class given this value or this data point that we are trying to estimate. So we are now assigned, let's see, the step 4. Now draw a conclusion. We now assign that observation to the class with the highest conditional probability. So in this case, the class with the higher conditional probability is the blue class, right? Because this 2 over 3 is greater than 1 over 3. So what it means is that this data point belongs to the blue class. That is basically how k-nearest neighbor works. And now I'm going to just explain this formula to you so that you get used to it. So this formula or this equation reads that the sum over n0 of the conditional probabilities of y belonging to j given x0. So n0 is the region. So when we make this circle, we are creating a region n0. So probability inside this region of this data point belonging to either one class or the other class. And that is why this formula, let me write it while I explain. Probability that y is equal to j, where j is at this point, j is 1 or 2, giving our observation x to be x0 is equal to 1 over k. Or let me just write it. Let me just write it a bit clearer. Let me not use 1 over k. So we are summing for all the times that we have the data point yi is equal to j, where j can be 1 or 2. In this case, I inside n0. So we are now dividing everything by the total number of items. In this case, we have 3. So we have over 3 here, we have over 3 here. So this is how k-nearest neighbor works. I may not have explained it perfectly, but it's explained perfectly well in the website. So as you are watching the explanation I'm giving, try to follow through by also reading the explanation here in the site. I'm going to stop here, and in the next lesson we are going to be looking at, let me see, minimizing misclassifications. So sometimes the classification might also not be correct, both in base classifier and in k-nearest neighbor classifier. Sometimes it may not be perfectly okay. How do we minimize misclassification in these classifiers? So that is what we are going to discuss in the next lesson. I would like to thank you for viewing. Remember to click on the subscribe button below to subscribe to my channel. Feel free to leave a comment for me to let me know what you think I can do better.